Hey y'all, Brent Wright with Additive America, and I am so excited to bring this information to you. I tell you, I wish that this information existed when I was looking for a 3D printer. And then on top of that, we have the opportunity to talk with Jackie Bailey, Ohio's very own certified prosthetist with East Point Prosthetics and Orthotics. We're going to do a Q&A with her just to see how adding a 3D printer has made a difference in her practice. But without further ado, let's hop in, and we're going to talk about how to choose a 3D printer for test sockets. One of the first considerations that you have to really think about is, do you already scan and do you know how to design? If you do not know how to do either one of those, a 3D printer right now for you is not what you need. You really need to step back and take a look at how to design, which will then allow you to 3D print. And before that, you even need to incorporate some scanning devices. So scan, design, and then 3D print. So if you don't have the scan and design down, it's not worth it to buy a 3D printer right now. However, as you'll talk to Jackie a little bit later on, she scans, but she doesn't design. The design actually happens at the corporate office of East Point Prosthetics and Orthotics, and then that file gets emailed back to her. And so you don't have to know how to design, but you do have to know somebody that will design for you to put it on your printer. So those are options. And the next thing is, you have to have a budget. I can't tell you how many times I've taken a call where somebody has said, "Hey Brent, I want a 3D printer." And I say, "Well, what's your budget?" "Well, I don't know. I want a 3D printer." And so the reality is, there are printers that are $200, and there's printers that go all the way up to $120,000, $200,000, and everything in between. So you need to have a budget number. Do you want to spend $300? Do you want to spend $1,000, $5,000, $10,000, whatever it is? And from there, you can really narrow your focus into what printers are available in the market for your office. The next thing that you have to do is ask around. Jackie is going to be right in your backyard. Pick up the phone, call her, email her. Say, "Hey, what printer are you using? What are the things that you are looking for in a printer?" My family and I recently got back from an RV trip all across the country where we met with multiple clinicians of varying abilities, skill levels, dollar amounts and all that. And I can tell you it was an amazing experience. And clinicians want to share their knowledge. Now, sometimes they're not going to share their secret sauce, but for something like this on, "Hey, tell me about how you chose your 3D printer," most clinicians are going to be happy to share that information with you. So just ask around. The next thing that you have to consider is customer service. If you go online to Amazon and buy a $300 printer, you need to know that you're going to be troubleshooting all your problems on Facebook, on the forums, and if you need to email the company, you're going to be emailing more than likely a Chinese company that is on a different time zone. There may be a language barrier. Who knows? So when your printer goes down, and it will go down, who do you want help from? And so you're not going to get a US-made, US customer service for $300. So you may pay a little bit of extra money to get the customer service. And I would say that is where a lot of the value comes in. Can you pick up the phone, get help the same day, in the same 15 minutes? Whatever it is, customer service is going to be the difference between a good experience for you and a not great experience. And it's a risk that you take. There's a continuum. The cheaper you go, the more you're going to have to invest and keep your machines going. The more expensive you go, the more customer service you're going to have for the most part, and your machines will keep on going and you'll have somebody to call. That's just the way it is. Now, the next thing is, we're going to go over the printer anatomy. So when we're talking and you're looking at specs, what do they mean? The specifications. So the first thing is, you have an X, Y, and a Z axis. The X axis goes across, side to side, left to right. The Y axis goes front to back, and the Z axis goes up and down. Then you have a couple other things that are important. You'll see specifications like a hot end and nozzle size. A hot end is simply where the filament goes in and then squirts out the bottom. That whole mechanism would be the hot end. And there are different types, different wattages, that sort of thing. But that's something that you're looking at in the specifications. And then you're going to whatever the platform is that you're building on it. We call it the bed. Or sometimes there's a heated bed where a platform is heated. I really personally like that option. I wouldn't look at a printer without a heated bed. And then you have your stepper motors. There's big stepper motors, little stepper motors. The size only matters really when you start getting into the bigger devices. The bigger build volume you have, the larger the step motors, for the most part, that you're going to want to have. So there's 3 different types. And those that are purist will notice that I have 3 on here, but there's really only 2 different types on here if you want to be technical. So the first type is called a Cartesian printer. And the Cartesian printer moves on the x-axis and y-axis, and then also moves on the z-axis. Everything is linear. We're going to skip the delta and we're going to go to the Core XY. The Core XY printer is different because the Y and the X are all in the same plane. But what's neat about a Core XY is everything's printing here, and then as you get height, the bed actually falls. That's a really neat option. Those are going to be some of your more expensive printers. But what's neat about that, especially is if you get higher and higher and higher, you're not going to get a wobble effect because the bed is moving back and forth. The bed is only moving down while everything else is happening around the top. It's a very, very neat printer. And then finally you have the Delta printer. Now the Delta printers are a wild set of printers. It is a round bed and it uses arms, and these arms have different geometries and they're moving all around. There's a lot of moving parts to that, but I tell you that there are some real advantages as far as speed and cost effectiveness. So for example, on Amazon, you can get a very affordable Delta printer called a FL Sun QQ Pro for roughly $300 to $400, and usually it's good to go out of the box. Just remember, there is no customer service, US-based customer service for that printer. And please, please know that you are going to be tinkering with some of these devices if it is less expensive. The next consideration that you have to do is materials. There are 3 main materials that we would use in the prosthetic and orthotic industry, and that would be PLA, which is a kind of a lower temperature plastic, but it's not super strong. There are some strong variations, but it's very cost effective. We would use this a lot in either some prototyping or upper extremity style devices where you're not going to be putting weight through it. You're also going to go to the other extreme where you have flexible material. So you may want to do some sort of flexible material for, say, covers or a flexible inner. Those are all things that you may consider. And then finally, PETG. PETG is a material that is essentially Vivac or Durplex. The neat thing about PETG though is we typically have known Vivac to be very fragile, and the main reason is when you pull a sheet or vacuum form, a sheet piece of Vivac over a mold, you're actually stretching those structures, the molecular structures around the mold, which can cause some issues and fragility issues really. It is more brittle when you pull it around. Now, when you extrude it through a hot end on a 3D printer, you don't have any of those stresses on it, so the PETG actually comes out very, very strong. And in fact, in our testing, PETG tests very, very well as far as strength for test sockets. So those are your material options. The next thing that you have to think about is how fast do you want to print? I remember when I first printed my first socket, I had to scale it way down just to print something, and it took 45 hours. And I, to be honest with you, I about threw my printer out the window. I was like, how is this even going to be effective for me in my practice? I don't understand. But the thing to remember is you give up things for speed, and we'll get into speed and resolution, nozzle size and all that in just a moment. But the thing that you want to think about is how fast do you actually need it? If you get a test socket in 5 hours, are you good with that? 10 hours, are you good with that? Because that does help direct you in the type of printer that you're going to get and what you're going to do to modify that printer to get those speeds. The next thing that is important is the nozzle size. Nozzle size is directly connected to speed, which is directly connected to resolution, which we'll get to in a second. So what in this picture, the top line, most printers ship with what's called a 0.4 millimeter nozzle. So it's 0.4 millimeters round. And so the filament actually squirts out that 0.4 millimeters round. If you use that material or that nozzle to print a socket, it's going to take not only a very long time, but you're going to have multiple layers and multiple passes to get your width. And all that represents is more potential for failure. So what I like to do is try to go to a much larger nozzle size to minimize those potential areas for failure. So the next line is a 0.6 millimeter nozzle, a 0.8 millimeter nozzle, and then I go all the way up to a 1.2 millimeter nozzle. A 1.2 millimeter nozzle spits out 9 times the amount of filament than a 0.4 millimeter nozzle would. And so your speed is going to be 9 times as fast. So a 36-hour print now becomes a 4-hour print. Significant difference, and it's going to be stronger. But what you give up is resolution. On the left side, you have something that is super, super accurate, but man, that's going to take a long time to print. On the right side here, you see these lines. You're going to see the lines in a 1.2 millimeter nozzle thickness resolution. But that's okay. For prostheses, it really doesn't seem to affect the fit. If anything, sometimes it enhances the fitting process. So I will always give up resolution for some speed. Now, some people will go to very, very large nozzles, and I try to stay away from that. You have a couple options there. There's a mode when you 3D print called vase mode, and some people will use vase mode where they will squirt out one single pass all the way up. That makes a prosthesis very strong. However, you have to post-process it, and there's waste. So you end up having to cut to your trim lines and then throw that other piece away. Yes, it's very strong, but there's actually more time involved from a technician or otherwise to get to that point, and some waste. I prefer to go with a smaller nozzle around either a 0.8 or a 1.2 millimeter nozzle, and I prefer to have my trim lines printed in the device itself. And then really all you're doing is smoothing the edges, and that's it. So you pop it off, you smooth the edges, and then you can go put it on the patient. Now I get a lot of questions, well, Brent, what do you do you send the patients out on it? So as long as you have done some of your own either internal testing or you've kind of piggybacking on some other testing, yes, you can send people out on the devices as long as you've got some quality control there. I always suggest fiberglassing the distal ends, just like we do with other Vivac sockets. There's always going to be a potential of failure in these test sockets, but you do what you can do to mitigate it. So I hope that helps you. The next question I get a lot is, hey, Brent, you just blew through a bunch of information. Now what? You didn't give me a name of a printer. You didn't do any of that for me. And that was especially on purpose. It is important for you to do the research on your 3D printer and you buy into the whole process itself. There are a couple extra questions. These are the bonus questions that you get. Do you want to get a purpose-built machine specifically for prosthetics and orthotics? Or are you going to modify a machine that's already out there? Those are really your only two options. There is just no machine out there that does it all. If you get a machine that's off the shelf, you're going to have to modify more than likely the nozzle size and even some of the profiles that go along with printing. If you get a purpose-built machine, somebody that's actually purposely built a machine to print 3D printed or prostheses, then all that work has been done for you, but you're going to pay a little bit higher of a premium. So now we're going to bring Jackie into the mix, and we're going to ask her a few questions. We have a very special treat here. We've got Jackie Bailey with East Point Prosthetics and Orthotics, certified prosthetist in your state, Ohio. So Jackie, just tell us a little bit about yourself, and then we're going to hop into the questions.
Yeah, absolutely. Like Brent said, I am working in Ohio here, born and raised in Ohio. Did my prosthetics certification course at Northwestern University. Did my residency with East Point Prosthetics and Orthotics in North Carolina, and then opened a branch here in Ohio to move back a little closer to family. I've got a daughter, a couple dogs, an awesome husband, and we are really thrilled to be back and closer to family. So that's been wonderful.
That's awesome. That's awesome. Well, we're going to ask you a few questions around really 3D printing. You're a pioneer in really the space. You were an early adopter of 3D printing. You have one in your office. Can you tell me a little bit about how that came about?
Yeah, absolutely. So when it comes to seeing patients initially, casting, I'm still casting quite a bit. I've used scanners in the past to scan limbs, but I love a hand cast. And so going from cast to a initial check socket, we have a relatively small office, don't have a huge lab or space for it. And so wanted to have a way that we could quickly turn around check sockets without having a lab. And so talking to Brent actually a little bit about this and some of the issues, and we were able to get our hands on a 3D printer that allows us to see the patient, cast the patient. We're mobile often. And so that's why we are still doing, most all of our clinicians are casting patients, hand casting. And so they'll bring it back to the office, or if they've got the time in the side of the road kind of a thing, can scan a cast, the inside of it right there, and can send it to the 3D printer, and it can be printed out ready to be fit on a patient within a matter of hours. We're talking like 3 at minimum, 7 at maximum.
Oh, wow. That's great. So would you say that you are an expert in 3D printing?
Oh my goodness, not even the slightest. I am no expert when it comes to technology, 3D printing. As a matter of fact, I remembered Brent when we had the conversation, thinking this guy is literally crazy. I am not getting a 3D printer in this office because I do not know a dang thing about it. And with a little encouragement and a few phone calls, it honestly, I will say, it honestly has been quite a bit easier to manage than I ever thought. And I'm being very truthful there.
So who runs your 3D printers?
All of our clinicians are versed in how to set it up in terms of just setting up a scan. And so it just, all of us.
Okay. And you said you've even had your administrative people run it before, right?
Yes, I was running out the door. I needed to get a print up and running and talked with Carol in our front office and said, hey, here's what you do. Can you go back and get this print started for me? And she also looked at me like I had like a third eye. And she called me literally cheering herself on as she had it starting up. And it was amazing. It was so funny. But yeah, she did it.
So the bottom line is if the machine is set up appropriately, you don't have to have somebody that has a college degree in 3D printing to run the machine. Is that a fair statement?
Absolutely.
Okay. So you touched on a little bit of the good stuff as far as, a quick turnaround, sometimes same day, or you let it run overnight and you can get it the next day.
Mhm.
Is there anything else good? And then we're going to go to, tell me some of the bad.
Yeah. So, like I said, the good is time management. The good is, would you like me to talk about materials now, or do you want to talk about that a little bit later, like costs and stuff?
Yeah, you can talk about that now too. Sure.
So cost has been really awesome. We use a PETG material, and it costs us roughly like $62 to $65 for a 5-pound roll, and we get uh, around 5 test sockets out of that, depending obviously on the size. If you're doing a lot of AKs or a lot of BKs, but I would say 5 is pretty common for us to get out of that. So we're talking what I think like $12-ish per socket. So that has been huge as well. And then just the ease of use has been a big deal because that was something that I've had in the back of my mind, thought we needed a 3D printer, but really was like, I just don't want to go down that road. I don't know anything about it. So the ease of use has been a huge thing. So I think those pretty well wrap it up.
Okay. So tell me the bad. What's the bad news?
Man, the bad is we had a couple of pieces that just because of how often we were running it just wore down. And I will say if somebody is in the market for a 3D printer, working with a company that has incredible customer service has got to be your number one, because I was able to call and talk to the guy who's building them. He knew exactly, with my seriously lack of knowledge when it comes to the parts, what they were called. I mean, I was sending him pictures and describing the color and the shape of the things, and he knew exactly what it was and said, oh, you need upgraded to this. We drop it in the mail for you. And most all the time, I don't think we've paid for one replacement part, because it's like, hey, you guys are using this, we're going to drop it in the mail to you. I can be on FaceTime to help you set that up, or we can make arrangements to come visit and do that ourselves. And so the bad part is we initially had some things that we've had to replace just because of the use and the product. And but on the backside, the customer service was really helpful in replacing that, and even I was able to do some of that. So I would say that, those are some negatives there. Another negative would be, this is not something that I'm putting patients on to, I would say, for extended periods of time to walk on. If you're working with prosthetic patients and doing walking test sockets, they're able to stand, they're able to take steps in it. I feel comfortable with that, but it is not something that I would want to send a patient home with for an extended period of time. So I think that's about all I can think of when it comes to the negatives there.
Okay. Well, I mean, just in closing, if somebody's interested in the technology, is it a direction that you suggest going, or say what would be a first step if somebody's like, hey, you know what, Jackie, I love what you're talking about.
Mhm.
What is the next step for me?
I would say reach out to somebody that has one that's in use. You're welcome to grab my name and number, and I will give you honest feedback if you want to share kind of what it is you would be looking to use it for, or I would be happy to direct you to the company that has made the 3D printers that we use, and you're more than welcome to chat with them. But make sure it fits within your realm and what you're looking to do. But I would 100% back you in saying if it's even a consideration, you should totally look into it because it has saved so much time for me from being in the lab, coordinating with the lab, all things like that. It has been really seamless in that regard.
Awesome. Well, thanks so much, Jackie, for being with us and sharing some of your expertise. And thank you
Mhm.
for being available for those that may be interested in going down that path. So I hope you have a
Yeah,
great weekend
absolutely.
and take care.
Thank you. Thanks.
Guys, thanks so much for watching and paying attention. It's been amazing to be with you. And a special thanks for Jackie for being with us. I hope you have a great day. If you want to know more about Additive America or get up with us, look us up on LinkedIn. We're on a ton of social media stuff. And then reach out to us if you want to know more about anything that we're doing in the 3D printing space. Thanks so much. Have a great rest of the weekend.